In this video, we're going to learn how to find the absolute extrema of a given function over a closed interval. And that includes the absolute maximum and the absolute minimum. And those values are guaranteed, the existence of an absolute minimum and an absolute maximum are guaranteed as long as the function is continuous and it's over a closed interval, meaning it's including the endpoints. And this is guaranteed by the extreme value theorem. Before we do some examples, I wanted to look at why it's important that the interval is closed. So if we look at the example right here at the top, we have a function that has an absolute maximum, but it does not have an absolute minimum, and that's because as we go off to negative infinity and positive infinity, the function gets closer and closer to zero, so it means that the values are getting smaller and smaller, but they never reach a minimum value. So in this case, we had an absolute maximum, but no absolute minimum. If we add the stipulation that it's over a closed interval, so for example, we had a closed interval 1 to 4, including the endpoints, then we are guaranteed an absolute maximum and an absolute minimum. So you can see here that the absolute minimum occurs at x equals 2 and the absolute maximum occurs at x equals 4. So again, as long as the function is continuous and it's over a closed interval, then we're guaranteed both a minimum and a maximum. So let's look at two problems, and the problems I want to look at are the functions that we were given in the last video. F of x equals 4x cubed minus 3x, and f of x is equal to x plus 1 over x. And in the last video, I found the critical points for each of these functions. So the critical points for this first function were x equals negative 1/2 and x equals positive 1/2. And then for the second function, the critical points were x equals positive and negative 1, so negative 1 and positive 1. So if we look at the problem as it was given in the last video, y equals 4x cubed minus 3x, we said that x equals positive and negative 1/2 were our critical points, and we can see here that here's x equals positive 1/2 and it corresponds to that low point, and x equals negative 1/2 corresponds to that high point. And those are local mins. One's a local min and one's a local max, but we do not have an absolute maximum value or an absolute minimum value. But what I want you to do now is I'm going to actually give you a closed interval on which to consider this function. And that interval is from negative 1 to 2. Okay, so I'm going to stop the graph instead of having it over the entire real numbers. I'm going to say just consider it over the interval from negative 1 to 2. And I want you to define or find the absolute maximum value and the absolute minimum value. And so what we do is we have our critical points and we have our endpoints, and the endpoints could be where that maximum or minimum value occur. So we have to test all of those points. So what I'm going to do is I'm going to test f of negative 1. That's my one endpoint, and I'm going to find out what the y value is. I'm going to test negative 1/2 because that's my critical point, and that could be where the absolute minimum or maximum occurs. I'm going to test f of 1/2, see what value that gives me. Again, that could be where my absolute maximum or minimum occurs. And then finally, f of 2. So I test my endpoints and my critical points. I'm going to see what the y values are, and then whatever the highest value is or the largest value is, that's going to be my absolute maximum. Wherever my lowest value is, that's going to be my absolute minimum. So let's go ahead and do that. So to make this easier, what I did is I regraphed my function and gave it the interval negative 1 to 2 so I could see what I'm working with on my graph. So I'm actually limiting it to that space between negative 1 and 2. And you can do that by just simply adding a bracket and then putting negative 1 less than or equal to x less than or equal to 2. And that limits your graph over that interval. And then what I did was I clicked on this button up here, the wheel, and then it gave me a table. And I put in my critical points and my endpoints. So I have negative 1. F of negative 1 gives me a y value of negative 1. F of negative 1/2 gives me a y value of 1. F of positive 1/2 gives me a value of negative 1. and f of 2 gives me a y value of 26. So we can see here that the absolute minimum is -1, and it actually occurs at two places. The absolute minimum occurs at -1 and at 1/2. So the absolute minimum is -1/2, and it occurs at two places actually, and that's okay. At x equals -1 and at x equals 1/2. And then the absolute maximum is 26, and it occurs at x equals 2. All right? So the next problem is y equals x plus 1 over x. And we identified the critical points for this function by taking the derivative and finding out where the derivative was equal to 0. And we got x equals -1 and x equals +1. And you can see these points on the graph. They actually lead us to the local min there at x equals +1, and at x equals -1 there's a local max. However, as it is, there is no absolute maximum or absolute minimum of this function or for this function. However, I'm going to give you a closed interval, all right? And this interval is completely arbitrary, but I'm going to give you the interval from 1/2 to 5. And I want you to consider the same function over that interval. And we know as long as the function is continuous over that interval, that because of the extreme value theorem, we are guaranteed a local or a global maximum and a global minimum. All right? So let me go ahead and show you what that picture looks like. As you can see, when we limit the interval from 1/2 to 5, there will be an absolute minimum and an absolute maximum. But we don't even need to draw the picture. What we can do is we can test the endpoints and the critical points. Now notice the endpoints are 1/2 to 5, so we don't even have to test this critical point because it falls outside of that interval. So all we need is to find f of 1/2, f of 1, and f of 5. And whatever gives us the largest value will be our absolute maximum, and whatever gives us our least value will be our absolute minimum. And so I can see from this table which I created, again, clicking on the wheel up there, you can create a table, and I found that f of 1/2 is 2.5, f of 1 is 2, and f of 5 is 5.2. So the absolute minimum is 2 and occurs at x equals 1, and the absolute maximum is 5.2 and occurs at x equals 5. And you can look at the graph and you can see that that's the case, right? The minimum happens right here at x equals 1, and its corresponding y value is 2, and then the maximum occurs at x equals 5, and its corresponding y value is just over 5, or 5.2.